In this video, we're going to discuss derivative as a function. From the definition itself, you can see the derivative at location x is defined as a limit here. Now, as you can imagine, after you simplify the fraction and send h to 0, x still remains. So the right-hand side is going to be an expression containing x. So we can guess it's some function of x. We'll see this from examples too. Now let's look at how derivative function compares to a function itself. So if we have a function with a graph like this, if you analyze the derivative function, remember derivative is like slope too, right? Slope of tangent line to the graph of f of x at each location. So if you check out the slope, you can kind of tell too the slope function, which is the derivative, would have a graph like this. For example, you can see here along the graph of f of x, if you draw a tangent line, the slope gets smaller as you move towards the right side, and the slope would be 0 here. Before we continue, let's check out the red curve, which is supposed to be the graph of derivative function or slope function. And it turns out it is kind of true. If you see the value, which is slope, right? The value is smaller and smaller, and it becomes 0 at the -1. Just like how we kind of say slope becomes smaller. It's very steep. It's less steep. So slope as function is decreasing value-wise. And at the -1 becomes 0. Once it crosses 0, the slope is going to turn to negative because the tangent line starts to decline. So you can see here it's true. Passing -1, we can tell the graph goes below x-axis, taking negative values. Anyway, so graphically, we can verify too. No matter what you have as a derivative, it's a function for sure. All right. Now let's see one example. So here we want to find the derivative of this function. First of all, at x, then at 2. Now, idea is if we find the derivative at x, which is not specified, right? And as we'll tell, it's a function of x. All we need to do is to replace the x in this function by 2, then we get this guy. So we don't have to do it twice. So let's find f prime first. Well, of course, we use the definition. So, all right, so by definition, the derivative is the limit of this fraction. Okay, so we're going to do first of all set up expression for this part. This part is a function itself. We already have it here. So we're going to set up the first part here, and also set up the whole numerator and simplify before we plug everything back here, the main word. Right? This is how we simplify, the look at least of our expression. Otherwise, if we do everything over here, it's going to be very intimidating. It's going to look very complicated. Okay, so let's see how we have expression for f of x plus h. I purposely put the f of x plus h under f of x just so it's convenient to, it's easier to set up this expression correctly. So algebraically, how do we do it? Very simple. We basically just plug in x plus h for x. All right, so wherever we see x in f of x, we're going to plug in x plus h for it. So x plus h goes in for x, and x plus h goes in for x here, and that's it. Now, I don't have much space left here, so I'm going to just discuss how we are going to simplify this, and then put the answer right here. So how do we simplify this? Well, we would square this out, x plus h squared, and use the formula square of sum, or we can use distributive property x plus h times x plus h, then times the 3 to multiply out. So if we do that, we will have 3x squared, 6xh, 3h squared. That would be the first term. And then the negative multiplied through. That's kind of obvious. All right, so we got the expression for f of x plus h. Now, let's see the difference here. So first, we're going to plug in this part for that. So 3x squared plus 6xh plus 3h squared minus x minus h. So this is the first term. The second is f of x. Well, it's up here. So we're going to have 3x squared minus x. Okay? And then cross out, for example, 3x squared and the 3x squared. It's 3x squared minus 3x squared. And then also there's x minus x minus x. There's subtraction in between. Without those terms cancel out, I have still 6xh 3h squared minus h left. So I'm going to then plug this into the limit expression on the top of the fraction. So I have 6xh plus 3h squared minus h divided by h. You can see the advantage of doing the algebraic work, dirty work on the side. So the main work here looks clean, simple. Otherwise, it can be very messy. Okay, so how do we evaluate limit? Well, h goes to 0, the denominator becomes 0, so on top, I'm going to first factor out h. h plus 3h minus 1. This way, we can cross out H. Then send the H to H to 0. Send H to 0, so this term becomes 0. The answer is 6x minus 1. So f prime of x, as you can see here, derivative, right, indeed is a function of x. It's a 6x minus 1. Now, if we want to find f prime of 2, just plug in 2 for x. Gives 11. All right, so the whole idea is giving a function, we find out its derivative as another function. You can call it like a derivative function, or in geometry, a slope function. All right, so this is a derivative function as a function. We're going to stop here.